Using recursive rules with sequences, part 2. So we're on example 3. We're writing recursive rules, and this one says write a recursive rule for each sequence. A part is 1, 1, 2, 3, 5. So to get from 1 to 1, there's no common difference. To get from here to here, you add 1. And here you add 1, and here you add 2. So there's not a common difference here. There's no common ratio either, no number that you multiply the same ratio to get to the next term. But is there a pattern? Do we see a pattern here? All right, so we have 1 and then 1. If we do 1 plus 1, we get 2. 1 plus 2, we get 3. 2 plus 3, we get 5. I'm guessing 3 plus 5 would be 8, would be the next term, and so on. So we can determine the pattern, and then 5 plus 8 would be 13, and so on. All right, so can we write a recursive rule even though this is not arithmetic or geometric? Remember, all arithmetic sequences have a common difference. All geometric sequences have a common ratio. So we're trying to write a rule for this sequence that has a pattern, but it's not arithmetic or geometric. So we know that we're adding the 2 previous terms to get to the next term. So let's think about how to write that. We know we have to identify the first term. All right, the first term is 1. And since both of the first terms is 1, let's go ahead and identify the second term as well. So we know we have A1 and we have A2. And then we can have A sub n, which if we're looking for the third term, we would want to add the first and the second term together to get to the third term. So how could we write that mathematically? All right, so A sub n equals, remember we used A sub n sub minus 1 to represent the previous term. So let's use A sub n minus 2 to represent 2 previous terms. And then we're going to add that to the previous term. So A n minus 1. And again, this is just math symbolism. What this is basically saying, if I put a 3 here, that means I'm going to add my second and first term together. If I put a 4 there, I'm going to add 2 and 3. So like right here, 1 plus 1 is 2. This is my first and second term. If I add 1 plus 2, I get 3. This is my second and third term, gives me my fourth term. All right, so again, if I put a 4 here, n minus 2 would represent the second term, and this would represent the third term. All right, so you need basically all of this information to write a rule for that, because you have to know your first and your second term here in order to get that rule. All right, so these may be a little bit more tricky. I don't think you'll have to do a whole lot of these, but again, it's about looking for patterns. Even if there's not an arithmetic or geometric sequence, you still can pick up patterns in different things. All right, so let's look at B part. We have 1, 1, 2, 6, and 24. All right, so again, there's no common difference because here you add 1, here you add 4, here you add a lot more. So let's see. There's no common ratio either. So what do we see? How can we relate these terms? So we have, this is our first term, our second term, our third term, our fourth term, our fifth term. All right, now if we look at it with our terms here, now I see 2 times 1 is 2, 3 times 2 is 6, 4 times 6 is 24. I bet the next term is 5 times 24. I bet that's what goes here. All right, so 1 times 1 is 1. Okay, so it fits that pattern. So this is n. This is our term, our number of terms. So how can we write this as a recursive rule? All right, so we first need to see that a sub 0 is going to be 1. All right, and the next term is also 1. And then 2 times 1, that's the term times this number in the sequence, equals the previous one. All right, so it's still going to be the previous term. So 2 times 1 equals 2, 3 times 2 equals 6, and so on. So that means a sub n equals n. Remember, n is what place it is in the sequence. First, second, third, fourth, fifth term. Okay, so n is the number, whatever your term is, times the previous one. So 6 comes from 3 times 2. So n times a to the n minus 1. So again, these are a little tricky. I really have to think about this in order to write this out. All right, so here we wrote a sub 0 equals 1, and here we started with a sub 1 equals 1. Just has to do with what you're doing to get the sequence here, because this took the previous 2 terms to add up to get the next term. We needed these to be our first 2 terms. But with a sequence here, we could call it a sub 0. It still is basically like what you're starting with. So this is your first term, second term. So if I wanted to find a sub 2, so if I put a 2 in here, I would do 2 times 1. 2 times 1 is 2. If I wanted to put a 3 in here, I would have 3 times the previous term, which is 2. Okay, n is 3. And then 3 times 2, and that would be 6. So again, it's always good to check them once you write a formula, once you write a recursive rule, then plug it in, check it, make sure it works correctly. All right, and here's a study tip. The sequence in part A of example 3 is called the Fibonacci sequence. And if you don't know what the Fibonacci sequence is, that's a sequence that shows up naturally in a lot of things in nature, and just everywhere you look, you'll see things that have to do with the Fibonacci sequence. So if you're interested in looking up something, look up Fibonacci sequence. It's pretty cool. And then the second sequence in part B lists factorials. And we have talked about factorials a little bit, but again, these are special types of sequences that you may see, but they don't necessarily fit into the same arithmetic or geometric pattern. Example 4, translating from explicit rules to recursive rules. Write a recursive rule for a sub n equals -6 plus 8n. All right, so if I want to find my first term here, a sub 1 equals -6 plus 8. N in this case is 1 because we're looking at a sub 1. So -6 plus 8 times 1 is 8. So -6 plus 8 is positive 2. So we can determine that our first term is 2. Now, take that and we'll use our general formula type that we had before. So we're going to have a sub n equals our previous term plus our common difference, and that was 8. That's given in both formulas, both rules. All right, once I have that, I know that I have to have my first term and my rule together. Well, not literally together. Let's see. I didn't finish one thought. A sub 1 is 2. My first term is 2. And then a sub n equals a sub n minus 1 plus 8 This is our recursive rule. So again, with the recursive rule, you do need to include your first term, which we were able to calculate by simply plugging a 1 into n to get that first term. All right, B part, a sub n equals -3 times 1/2 raised to the n minus 1. So hopefully you recognize this as a geometric sequence where a part was an arithmetic sequence. So again, just getting familiar with these general formulas. All right, so again, we want to find the first term. So we're going to say a sub 1. And that's a really sad looking a. Let's try that again. A sub 1 equals -3, 1/2, and then 1 minus 1, which is 0. And we know that anything to the 0 power is 1. So we've got -3 times 1. That's just properties of exponents. So we know our first term for this one is going to be -3. So we already have the common ratio, which is 1/2. So we're going to take our first term and we're going to write that with our rule. A sub n equals 1/2 to the a minus 1. And that would be our recursive rule for that geometric sequence. Example 5, translating from recursive rules to explicit. All right, so now we're going in reverse. Write an explicit rule for each sequence. So this time we're given a recursive rule and we want to write an explicit rule. So the first thing we need to do is identify what we have, what's given. So we have the first term is given as -5. You can see that's right here. The first term is -5. And we have to see what the common difference is, and it is -2. So we have a sub 1 equals -5, and we have our common difference of -2. And both those were given right here in the recursive formula. So now remember back, the explicit rule, that's the one that they're going to give you on your EOC reference page. So you just have to look at that, and it'll be a sub n equals your first term plus n minus 1 times your common difference. So here we're going to have a sub n. Our first term we identified as -5. And then we've got n minus 1. And our common difference is -2. And we can distribute that -2. We can simplify this a little bit. So we're going to have a sub n equals -2n plus 2. We're going to have a sub n equals -2n, -5, and 2 is -3. So you can switch the order around there. If you put the -3 first, it's fine. But I'm used to putting this in slope-intercept form. You can see this represents a linear equation if graphed. All right, for B part, a sub 1 is 10. We can see that our common ratio here is 2. And this one represents an arithmetic. So we're going to, not arithmetic, geometric sequence. So we're going to have a sub n equals our first term, and then times our common ratio raised to the n minus 1 power. Again, this formula will be given on the EOC reference page. So we've got a sub n equals, our first term is 10, times our common ratio raised to the n minus 1 power. So this would be the explicit rule for B part.